Determine the long-run behavior of the function f of x equals 4x to the fifth plus 6x to the fourth minus 3x plus 10. So to determine the long-run or end behavior, what we need to look at is that leading term, the one with the highest power of the variable, 4x to the fifth power. And that's the one that will determine the end behavior. And so all I need to do is look at that term, and I see that it is odd degree. And it's positive. So it should look, in terms of its end behavior, it should have end behavior that matches the graph of y equals x to the fifth power, which is just similar to our cubic toolkit function. So we're not saying the graph looks exactly like y equals x to the fifth power, but it has the same end behavior, which we should be able to picture then on the graph, that as x goes to infinity, y goes to infinity, and as x goes to negative infinity, y goes to negative infinity. And so we get that just by relating it to the similarities it should have to the y equals x to the fifth or odd power function. So its graph, we know now a little bit about what the graph of f would look like. We know that eventually it goes off this way, just like y equals x cubed or y equals x to the fifth would, and likewise over here it heads off that way. Now in between, what happens? We don't know yet. What happens in between, the intercepts, the turning points, the maximums, and the minimums? Those are all questions of short-run behavior, and we'll be answering those kind of questions a little bit later. For the long-run behavior, that's what's going on out here as you head off to positive infinity or negative infinity.